All right, 2020 Toyota RAV4 air conditioning. Pardon the noise as a vehicle being cleaned right next to me with a power washer. So I'm just showing you here the first few minutes of operation. Let's take a look at that. So we started at nearly 80 degrees. You see that red line up there? It's just below 80. It was actually above 80. By the time I turned on the data recorder for interior temperatures, it was already about 4 minutes. So we're going into, there's 4 minutes right there. So that means it's been about 8 minutes. And you can see the interior temperature right there. The interior temperature is dropping. And it's down to 61 degrees interior temperature. Let's see, will it focus? Come on, Apple, you can do it. Yeah, hunk of shit. There you go, 61 degrees. And if we follow it up, it was above 80 when I started. So the temperature's been coming down and we're down to 37 degrees Fahrenheit. This is a hybrid. It is an electric compressor. It has a brand new fan assembly. It has a brand new condenser. Ooh, and we're down on, he filled this up already once again. So that what that means is he did not properly fill this up. He did not use vacuum. And he just filled it up and it's went all the way down again. So yeah, that's a problem. And I did ask him for more coolant and he says there is none. There is no excuse for any shop to not have Toyota long life coolant in your shop, especially when you get Toyotas in your shop every day. And when this is a continuous problem inside a shop, time is being wasted because you gotta wait for coolant to be delivered every time on every car, and there is no excuse for that. Just like not knowing how to properly bill and then complaining that you're always out of money and that times are tight. Times are only tight due to lack of knowledge. So let's see, what do we got going on here in pressures? There we go. We're at 109 PSI on the high side, low side's at 30. Let's look over time. As you can see, we were 111 PSI, and will it focus? 111 PSI at minute 4, which is about minute 8, and right now we're at 108 PSI. If you take a look at our superheat and subcooling, we're now at 3129. Now before, when I started and this thing was ramping hard on this electric compressor, the superheat, subcooling, not what I'm looking over there, the superheat was down to almost 0, between 0 and 5. It was going between there the first few minutes. Now that we're going into about 9 minutes, and it's satisfying the indoor temperature. If we were watching, say you had your all data, your scan tool hooked up, and you were looking at the RPMs of the compressor, because this is an electric compressor, you'd see it's ramping down. Before, the suction line temperature right here, that was at 37 degrees before, and now that we don't need cooling because it's already cool in the cab, it has raised the temperature of the evaporator, because now we're at 62 degrees, because the passenger compartment does not need a lot of cooling because it's satisfied. So let me get it, I have it in recycle. I brought down the temperature of the cab. So let's put this on ambient air, not recycle. Where's our air? Our air gets drawn in right here. It's only, the engine's only a little warm. Not warm enough, and it's not a warm enough day because it's winter time. But you can see it was 37 degrees Fahrenheit, but it's no more. And let's get it out of recycle so we could take it off into fresh air. Let's get it on low. I want to make sure. No, we'll keep it in low. I don't know. I'm trying to listen for the recycle to come off. Well, I'll tell by the pressure in a minute. The pressure on the low side will go up for a second, and then the compressor, the software will kick in and eventually speed the compressor back up to compensate for that. Oh yeah, we're working. Remember, we're 20-some, 28, 29 degrees superheat, and now it's falling because it's working harder. And look at our low side, pressure's going up a little bit. And I can hear the compressor buzzing down there. Just a little bit. And you see our suction line temperature dropping? Right there. 50 degrees, 52 degrees, 53 degrees, 54, right there. So hot air is being drawn in over here. So the software is going to tell the compressor to spin up a little bit because hot air is being drawn in over the evaporator. You can see right here, and let me see if I could focus in for you guys. You can see right here, our low side pressure went up to 36 PSI. It was at 31 PSI. Look at our high side. This is where we were, 108 PSI, but this is where we are, 124 PSI, because we're drawing in the air off of the catalytic converter. The exhaust manifold right here is being pulled up, plus we have the fan going. So we have the heat of compression on the condenser. And are we hot in the heater hose? I feel, no. The heat, what in the hell? The radiator's not hot yet. No, ice cold. Ice cold. There's absolutely no radiator heat that is being drawn from this fan that is on, being pushed over here. So all the heat that's being drawn into the fresh air intake is strictly coming off the catalytic converter and the exhaust manifold. The engine is cold because it's only started a few times because it's an electric. There is no heat being generated by the mass of the engine. All that heat that you see going up right there is strictly from the catalytic converter and the exhaust manifold there. There's no engine block heat. All right guys, just a little experiment, let you guys see what's going on there. And as you can see, your superheat, what it does. Catch you later. I gotta get onto some more vehicles, and that's all I have for today for time for making my one shot a day.